Hello and welcome to Aerotech's Automation1 version 2.7 motion control platform release update. Aerotech is a company that solves your toughest precision motion automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, PC and drive-based control hardware, and hardware-based drives for servo motors, galvo laser scan heads, and interfacing with other devices. In this video, you will discover new features available in the 2.7 Automation1 release. This includes beta features such as 3D plotting, custom modules and MachineApps, cutter offset compensation, task variables, and I&I file support. New features include the new Modbus TCP IP for drive-based controllers. This is coming out of beta, so it's new. New program variables in a watch window, and new string variables in watch windows. The studio improvements are vast. We've done a lot of things with data collection configuration, sidebar improvements. We've added Motion Plus Modus 1 belt drive support, and frequency response module improvements. Other improvements persist throughout the entire technology stack, including AeroScript improvements, Automation1 help improvements, controller improvements, API improvements, MachineApps improvements, and drive hardware improvements. So my name is Patrick Wheeler. I'm a product manager for Aerotech. Let's get started. First off, the beta features. First one we're going to talk about today is 3D plotting. This is something that's new to Aerotech as a tool. We didn't have this in our previous generation controllers, so we're excited to introduce this to the market. This allows you to configure 3D data signals in the data visualizer module, specifically the configure signals dialog. Then adding data signals to the 3D configuration will also automatically add them to the 1D configuration. So kind of a 3-for-1 deal you get there in configuring. Then after you've configured your data collection, you will trigger your 3D data collection using AeroScript functions, or equivalently the data visualizer controls. As you see above, there's a set of push buttons for triggering one set of data, triggering n sets of data, or triggering a continuous data collection. Okay. Once that has been collected and the data is actually being visualized, you will view this in the two new visualization tools we have. The first is just your 3D signal viewer, and the second is your 1D and 3D being viewed concurrently. The nice thing about the second tool there is that cursors in the 3D and 1D line up. So you can see that I've sort of clicked on the 1D to these two kind of peaks in the sinusoid of my position command of Y, and I can see exactly where those different cycles show up in my 3D position command feedback signals, my position command signals that I'm showing in a 3D view. So this for us is a first release of 3D plotting. We're calling it beta. We're looking to learn more. We're looking to learn more about what you need. So talk to your local field sales engineer. Give us feedback on what you like about this, what additions you'd like to have, and let us know at Aerotech, and we'll do everything we can to get that into the application. Next up is a new tool called Custom Modules and MachineApps. So let's have a quick review here for everyone who maybe needs to learn a little bit more about what MachineApps is. There's plenty of video content on MachineApps available to you. But MachineApps is a tool that allows you to customize user interfaces to be built for machines and motion systems that already use the Automation1 controller. So it's meant for people that are already in our product line to be faster and quicker at deploying their front end. You develop these MachineApps using the MachineApps workspace in Automation1 Studio. That is a tool that you would have to pay for in a configuration of the Automation1 MDK. And then it allows you to use a drag, drop, and configure approach, basically dragging pre-designed software modules into predefined spaces for you in an HMI layout. Okay. So it's very quick and easy to do this. You know, it's kind of building on past products we've done on HMIs, but making them much more flexible and much more up to the user's creativity as to what your actual HMI would look like. So custom modules is taking that a whole new level. This is a new feature. It's beta in 2.7, but custom modules, they let you develop new custom modules that can be integrated and deployed with the standard modules I described above in a machine app. These custom modules are unique. They are written in C#, as you see in that last bullet point. So you're developing literally by coding them. And then it allows you to interact with the Automation1 controller and other parts of the Automation1 machine apps application. They can contain other functionality. They can access local hardware and file systems on the computer where the machine app application is running. They can reference other .NET assemblies, native DLLs, or configuration files, and they can rely on drivers or other installed applications or components. So this really, you can pull your process tool or your process capability as a module inside of a machine app. Okay, so maybe that's some kind of image processing. Maybe that's kind of a sensor integration. Whatever it might be, now your front-end development can be a lot less by leveraging the pre-configured tools from Automation1 and Aerotech and just doing the targeted design of the one module you need to be different, or maybe the one or two modules you need to be different. Okay, so this is going to give you lots of flexibility. And what it might look like is here on the screen you see here in the image, most of the modules here are Aerotech standard modules. Only one is custom. It's the one there on the top right labeled custom module. And that is a laser recipe manager developed by our application technology team as an example for this demonstration. The actual programming model, data visualizer, and camera, those are all standard machine app modules. So is what's called the operator control, or the custom buttons, the indicator module. And down along the bottom is what we call our Axis dashboard. So as a developer, there's a total of 6 different items here, and 5 of the 6 you don't need to develop. You only need to develop the one custom module to get the functionality this machine needs. In machine apps, it's also important to note you're not finding the A3200 or Automation1 or Aerotech branding anywhere. You're only seeing your brand. You can add custom icons, custom colors. There is a machine apps launchpad that allows you to put a custom image on it, and you can kind of abstract away from the user that Aerotech even exists, right? I'm sure we'll do more on the branding side of things to make it even better for our customers. Cutter offset compensation. For most of the time, Automation1 has had a radius offset, so cutter radius offset compensation. Now we've added cutter length offset compensation. It's easy to use. You configure it with AeroScript code. New AeroScript functions were added for this feature, and then you enable and disable it with G-code commands. Again, I tell people this all the time, you're not paying extra for G-code with Automation1. It comes with every single controller we sell. It is a part of the AeroScript programming language, so it's always available to you, okay? You do have to be mindful of your lead on and lead off moves when doing this, but that's something that all process developers kind of know. And then coming soon, Automation1 tools. So now that we have all these nice offset compensation features, we are going to give you the ability to define your own tools that you can access in Automation1, and we are making sure that that new feature of tools will be very flexible for the wide variety of different process tools our customers need and use. Next up, as a beta feature here, are task variables. There are now task array variables for each task. Those include an array of task variables of the real data type, the integer data type, and the string data type. Again, these are used to communicate between iterations of a program that are running on the same task. The number of available task real variables are specified by the task reals, and the integers by task integers, and the strings by task strings. Different from controller global variables, you cannot use task array variables to communicate between tasks. They are meant for their own specific task. And then on a reset, the reals and the integers will initialize to 0, whereas the strings will initialize to an empty set. Another feature I'm excited about here is the INI file support. This is beta in version 2.7. We had an example of an INI file support in previous versions of Automation1, although it wasn't really fully functional as it was in our previous controllers. So this really brings all of that functionality into Automation1, which will make interfacing with INI files a lot more user-friendly, okay? So in this example I have to the right, we have 3 different playing surfaces, a baseball field, a basketball court, and an ice rink, with a series of descriptors underneath them. Those descriptors you would kind of refer to as keys in an INI file nomenclature. You can put these keys and their values into groups called sections for organization. And then the INI file functions that we've created in 2.7, these are AeroScript functions, allow you to read a value, modify or create a value, a new value. You can search to see if a section exists. You can delete a section or a key. Common machine builder use cases for INI files include saving and accessing machine and tool positions. So sometimes you might have a machine with several tools. You might have a machine with several different like fixturings and things such as that you want to save the positions of things for later use in programs. And it's also really good for saving and accessing process set points and values depending on what your process might be. They work well. INI files work well with features such as the new cutter offset compensation, work offsets, and other process specific parameters. So take a look at these INI files if you haven't used them in the past. They're a very convenient way of saving important values for your machine control and accessing them later to make your programming a little bit easier. New features. The first new feature was a beta feature before, Modbus for drive-based controllers. It is now out of beta. Now, the PC and drive-based controllers, or all Automation1 controllers, support Modbus TCP IP. This is an industrial Ethernet protocol. Common uses include communication with PLCs, I/O modules, and other simple field buses or I/O networks. It is an automation standard protocol. It's been around for a long time. It still has a lot of use in industry, and now it's supported by Automation1 drive-based controllers. Looking at the table below, our standard option on the ISMC controller includes the CP0 option, which means by default, you will always have one Modbus server and one Modbus client connection on all Automation1 controllers. Now, if you want more connections, you can order the Controller Plus option, CP1, and get 16 Modbus clients, okay? So there's a way to kind of, expand your control, as they say. All right? Next up is our Programs Variable tabs, or what others may be referred to as a watch window in versions of our controls in the past. This Program Variables tab is a great feature for debug and setting up programs. It lets you inspect variables that are in scope while a program or library is paused. And while you're debugging, after every single execution of a line, you enter into paused mode. So it's really, really helpful for paused programs because these values will all be populated. In this example, we've run through this for loop. We're on our counter instance 18, and new value is at 47.5, and old value is at 45. Once I execute line 8 of this code, 47.5, or the value of new value, will be assigned to old value, and we'll just keep counting through several iterations of this counter till we kind of get to 99 and get jumped out, okay? And you can kind of step through using the debug controls. I'll scroll up here. This is step over, step into, step out of controls for walking through your program in a controlled manner. As a note, data type struct and array cannot be inspected with this tool. Next slide here is our global string variables watch window. This is a new feature. We always supported global integers and global reals, but now we support watching the values of global strings. So to demonstrate this, I wrote a quick little program called strings.AeroScript, and you'll see that I did two different examples. One where I actually created a string variable called text and assigned that to sglobal0, and the second is where I directly assigned text to sglobal1. In both of those cases, as I execute those lines of code, the value of these two string globals in the variable watch window were updated to what I assigned them to be. So that's very nice for inspection as you're actually doing some process development. Studio improvements. The first thing we're going to go over here in Automation1 Studio is our configure signals dialog, which is part of our data visualizer module. The data visualizer module shows up both in the visualize workspace and in the develop workspace. And a big highlight here is just the overall layout of this tool, right? You'll see it's kind of split up into three main sections. The first are your 1D, 2D, and 3D tab views. Right now you're looking at the 3D view, where you can configure an XYZ or any number of axes and hit add to 3D, and the 3D signal you've added will show up now in the center section that lists all of your signals that you have configured for plotting 1D, 2D, and 3D signals. Okay? So each one of these signals that you have configured for plotting can be configured. And those configurations are managed in the properties called flyout window on the right-hand side. So you'll see here I show the flyout expanded. I also show the flyout compressed. Should you not really want to dive into any of these properties, you don't need to. You can use application defaults. But if you do want to do some customizations to the colors, the labels, the scale factors, the offsets of your signals, you can simply open the properties flyout and start configuring. To get out of this window, you'd either cancel or more likely hit update. And now your data collection configuration has been configured. And if you use something like the app data collect AeroScript callback functions, when you trigger data collection using those functions, you will collect data as it's configured in this window, okay? So it's very, very nice for that reason. You can toggle to hide, not hide and show signals with the eyeball there. You just click on the eye, it'll go gray, and that means that even though you're collecting that data, it will not show up in the data visualizer window, but you will have it in your file should you save that file. Okay, so it's truly configuring, the signals you're going to view by toggling that on and off. All right. When you have collected data already and you're in a current plot, we have now moved the edit plot capabilities outside of the configure signals dialog and into its own dialog or own window for a customer to use. This kind of makes things a little bit more clear. The edit plot is right there in front of you. All you have to do is click on it and this window will launch. If you see there underneath the 1D signals, there's a whole series of signals that are shown as like not being plotted. The eyeball is gray. Those are not plotted by default, but these signals are collected by default with every data collection. So even if you don't pick these, there's a series of signals that Aerotech has designed to always be collected with every data collection. We know from experience these are useful for troubleshooting and optimization, and it is very frustrating when you've collected data and you go back to look at something and you're like, oh, why can't I see the current command, or why can't I see the velocity feedback? Well, that's because you didn't choose it, but we work around that by always choosing the most common signals for your later troubleshooting and optimization efforts. Okay, so when you go in and edit a plot in the dialog, you can choose to show or hide signals. You can change the signal properties with the flyout there. You can add 2D or 3D signals or remove those signals. And then really kind of a nice user experience here is like once you've set things up here in your edit dialog, you can click that button on the bottom left and you can set your data collection configuration to be as defined when editing a current configuration. And what that means to you as a user is it'll overwrite what's currently configured, and the next time you go and plot a signal, you will get it as edited here the last time you edited it. But make sure you click that before you exit, okay? Unless you don't want to apply this to the next signal or the next set of data you collect. Another improvement we made, there was 2 different sidebar modules that were improved. The first was a quick navigation sidebar. We updated the visual design just for some consistency. We improved the different search results. One, if there are no search results, it clearly tells you that. It has additional keywords to improve your search results. We also made sure that the module you were navigating to is not hidden. So for example, if you wanted to go to automatic encoder tuning, but for some reason that was kind of hidden in your application, you couldn't find it, that used to be a problem, it no longer is. And then software updating is now accessible as a search result as well. We also updated the checklist sidebar module in 2.7. This one feature it has, which is really nice because absolute encoders seem to continue to get popular, is this improved integration of absolute encoder setup. It now sends users to the absolute encoder alignment module when you actually have an absolute encoder on that stage. It also responds to changes made to axes in machine setup and prompts users to recomplete items invalidated by a new configuration of an axis. And finally, the checklist items can now be included in MCD files that are downloaded from or uploaded to a controller in Automation1 Studio. Okay, so a little bit more flexibility there on your checklist items and how they're included in your machine controller definition file or MCD file. Another improvement in Automation1 is that we added Motion Plus Modus 1 belt drive stage support to the machine setup wizard. Okay, so what you're seeing here in the screenshot here is a software screenshot of machine setup where you actually search for belt drive linear stages underneath Aerotech standard products. And what comes up are these 3 products from our friends here at Motion Plus. The new stage they have recently released to the market is called Modus 1. It's available right now in a screw-driven version and a belt drive version with a pending linear motor version as well. Each version is offered in 95mm, 125mm, and 170mm wide frame sizes. You see those 3 images down in the bottom, left to right, 95, 125, and 170. The Modus 1 belt-driven stages are unique in that they maximize your payload and actuator speed. They do have a compact footprint. They are ideal for pick-and-place part shuttling and gantry type applications. They have great lead times and in-stock options. And the Modus 1 screw-driven stages are already accessible in machine setups. They're not shown in this filtered view, but they are available just like the belt drive stages are now in 2.7. So go check them out at motionplusmore.com and see which Modus 1 stages might fit the needs of your applications. They are lower cost than many Aerotech stages, and they again have on-the-shelf options available for purchase. If you want to do your own custom belt-driven stages or have some other third-party belt drive stage, You can now configure that in a device catalog. You can add it as a third-party device, and then it'll be accessible for you in machine setup. Machine setup was also programmed in 2.7 to do some better jobs at determining servo gains for belt drive linear stages, and also servo loop gains for well-loaded belt drive stages, okay? So we're making some decisions there on gains in order to get you out of machine setup with a more accurate and operational set of gains for your precision stages. In the frequency response module, we made some continued improvements. Now the current loop responses and feed forward responses have available loop shaping, okay? So now you can do some damage with current loop responses and feed forward responses. There is an expanded set of servo and feed forward gains in the loop shaping toolbar. And also we now have the frequency response module now has new settings to further customize your sinusoidal, your white noise, and your multi-sign measurements. This is a nod to Aerotech and our love of controls. We continue trying to make the core servo motor tuning and controls tools better for customers and for our high-end users that really want to dive into some of these really specific use cases of frequency response servo motor tuning. AeroScript improvements. So a couple things we did here, I'll kind of summarize on this slide. I'll go through those real quick. One, the stability analysis improvement, and you can now run a stability analysis from AeroScript using a callback function that we added to the programming language. You can retrieve MCD parameter values. This is a really nice feature for people who maybe need to change values of parameters programmatically, but want to go back to their original MCD value. You can now do that with a series of AeroScript functions. The user-defined task errors and warnings, you can now add a little text string to the task errors and warnings. That's really nice for machine builders who want to communicate to operators what actually went wrong. You can make that description whatever you want it to be now. Check that out, that's a nice feature. And also we added line breaks and comments, and that enables you to put a line break and comments in the middle of some AeroScript statements and expressions. For example, if they are very long and you want to break them up, okay? You can do that over multiple lines now. Help improvements, and this is just kind of the tip of the iceberg here as we continue to improve our help files. A lot of the things that we've been working on for the last couple of release cycles are now starting to come out to be market facing. First one you're going to see as a customer is the reorganization of the table of contents. We also improved collecting data and the visualized workspace help pages. The screenshot on the right is a visualized workspace help page. As we kind of get a little bit more maturity in the application, we can add screenshots and things with a lot of confidence that this is exactly what it's going to look like, because things are changing a little bit less rapidly than in the earlier versions of Automation1. So more screenshot and more kind of digital content you can expect in the help files we move on. We also changed the layout of some of the overview topics for better usability, and we improved search results and included more relevant linking between pages as well. Moving on to controller improvements. One that we're really excited about here is an enhanced scanner control. This is targeted at our laser scan head customers. So if you're buying the AGV HPO or AGV XPO from Aerotech with the Automation1 GL4 drive, this is going to apply to you. And if you're not buying those products now and you're a laser user, shame on you for 7 weeks. These products are really industry-leading, top-of-the-line products from Aerotech. Now, enhanced scanner control really takes that to a whole new level, okay? Enabling you to settle faster, settle within your settle window faster, or stay within your settle window. And you might even eliminate the need for any kind of jump delay. And we're going to show you that in the graph in the top right. You can accelerate faster, which enables you to achieve higher velocity motion in all of your short moves, and then decrease your tracking errors for all your moves as well. So in the graphs on the right, let's go through them. The first one is a step and settle test we did with a 0.3 millimeter step size, a move time of 250 microseconds, and a settle window of 3 microns. We were doing that with the HPO scanner, the AGV HPO, at about 105 microseconds. We added this new enhanced scanner control to that same mechanical device and got all the way down to 275. And then we did it with the XPO, which is our best mechanical design in laser scan heads, added enhanced scanner control, and we were never out of the settle window. 0 microsecond jump delays, okay? Very important for process throughput times. Contouring applications. Now we're trying to trace a circle and stay within 3 microns. It's a 300 micron diameter circle, so maybe 1% circularity error we're looking for here. Our max speed with HPO could only get up to 4.4 meters per second. With the XPO and the enhanced scanner control, we're up to 2.7 meters per second. We are cooking now. We're going so much faster. You're going to get so much more throughput on your system, and you're not going to have more error. In contouring, very similar to the circle test, this is for a 3mm radius corner. Again, with the XPO, we're getting you much higher throughput. We're more than doubling your HPO throughput you're used to getting today. So if you're not buying the XPO from Aerotech yet, and you care about parts per hour, you care about part quality, you want to have industry-leading throughput for your machines, call Aerotech today and get in an XPO with enhanced scanner control, and you will have the industry's leading performance in laser scan heads. Other controller improvements we made. InTime 7, we're starting to roll this out. The first attempt at this is really just to say, okay, if you don't have InTime installed yet on your PC, we're going to install version 7.0 23244.1. If you already have InTime 6.4 or a version of InTime 7 already installed, say a previous version, we are not going to touch that. We are not going to update it at this time, but we are going to try to move more and more customers who are maybe back InTime 6.3 or previous into a newer version of InTime. That's the step we're willing to take right now. It's important to note that InTime 7.0 supports newer PC processors and chipsets that InTime 6.4 does not support. You can go to our PC-based controller selection guide. It's underneath our help files at aerotech.com, and you can learn more about PC selection and what you need for Automation1. In the controller, we also added gearing and camming improvement to allow your sync ports A or B to be used as your gearing source or your camming source. Moving on to API improvements, and these really mirror the improvements we made throughout the application. The first improvement of note here is the ability to get and set industrial Ethernet variables, such as Modbus and EtherCAT, via the APIs. This improvement goes really nice with drive-based Modbus, which was taken out of beta in this release. We also added the ability to get and set controller task variables via the APIs. So task variables are a new feature, and they're also accessible through Automation1 APIs as a new beta feature. We also added the ability to change the task retrace mode, feed hold state, and MFO percentage through the APIs. So much like we gave you that capability through a machine app, if you're an API user, you also have that ability to add to your application. In MachineApps, of course, you already know about custom modules. We talked about that earlier. We made another improvement of note, and that was essentially that the CNC features have been added to MachineApps. The feed hold button, if you look at the kind of call out here, it's grayed out right now because the program's not running. Should it be running, you can hit feed hold. It would stop the motion where it's at and just kind of put a hold on it. While it's in feed hold, you can go and change your MFO value or your manual feed rate override. If you are moving at, say, 3 meters per second and you change that to 50% and hit play again, your motion would proceed on, but it would proceed on not at 3 meters per second, but at 1.5 meters per second. You can actually retrace your parts. I don't have that enabled right now on this example, but that is another feature that's available, and you can select those through the edit module configuration dialog when you add this programming module in the machine app that you were designing. So this, again, the programming module is available in the Automation1 Studio, but these tools are not available. The programming module has more features available when you use it as a machine app, and that's because these tools are being deployed for an operator or for an actual workstation, whereas the Automation1 Studio is intended for a developer. Okay? Drive hardware support in 2.7. Let's talk about some of the firmware improvements we made. The first one, and we did this because we get some situations where there's a special motor design and the average current time of 20 seconds is not long enough for the amount of current or RMS current that motor can withstand over, say, a longer period of time. So we increased that period of time from 20 seconds to 2 minutes so we can actually stress those motors a little bit more. This is something you should not change unless you know you have to based on your application. So if you do want to change this, you do have more flexibility, but please be careful that you do not damage your motor by exceeding the RMS current that it is rated for. PSO, we added some flexibility to PSO. The first thing of note is that we added the ability to configure the interaction between the PSO waveform delay and the external synchronization signal. So for some PSO modes, you are actually waiting for, say, an external sync signal from something like a mode locked laser. Even though you might have a PSO firing event ready to go, it waits for that next synchronization signal. And now with this PSO waveform delay, you can add an additional delay after that synchronization signal came in. You can also now do an average, a sum, or take a difference of two input sources ahead of PSO functionality. So if you say, for example, are tracking a stage position with two different encoders, and you want to take the average of those two encoders to use as your PSO tracking input, you can now do that. There's better fault tools. You can better isolate the cause of the feedback input 0 and or feedback input 1 faults. And we talked a little bit earlier, I believe, about some of the troubleshooting guides we've been adding to the controller help files. All of these subbit codes are added into the feedback input 0 and feedback input 1 fault troubleshooting guide inside of the Automation1 help files. And also now a drive will generate an amplifier temperature fault if it detects a problem with the temperature sensor. So it's not just set the temperature one high. If it detects an issue, it will also generate a fault. And finally, we did improve data capture with the ability to reset the drive data capture configuration to its default state using an AeroScript function. So lots of different firmware improvements ongoing in 2.7. Next up, and this was a whole other thing we just launched, is the Automation1 IA4 and XA4. These products just launched in January of 2024, so they're relatively new to the market. We are building these in stock right now, so please place your orders now and expect quick delivery. An Automation1 XA4 and really an X drive in general can do it all, and that's what this is supposed to show you in a very, very brute force kind of way, I guess. So one thing to tell you is that with an iDrive or a drive-based controller, the controller runs on the drive. So that drive is really two items. It is a full motion controller and it is a multi-axis servo motor drive. That's what you're looking at right in the middle of this screen. So it controls these two axes, but it also can go over our hyperwire network and connect to multiple other axes as well. So the regular XA4 cannot run the motion controller, but it can control two axes of servo motors. You can connect a PC to an iDrive. Now that PC does not need to run the real-time operating system for the Aerotech controller. That controller, again, runs on the iDrive. But you still can create a custom Windows application with MachineApps and connect to the iDrive and control your application with an Automation1 HMI tool. You can connect a camera to your PC and look at that camera through a Windows HMI MachineApps application. You can integrate a safety controller with an iXA4. You can do that by using the Safe Torque Off input on the top of an iXA4. The iXA4 can be configured with EtherCAT. It comes standard with Modbus. So you can use EtherCAT or Modbus to connect to third-party I/O devices, like is shown in this drawing here, in this sketch here. And then finally, all the other connectivity tools also work with the iXA4 in this image, meaning that you can talk to it via the socket interface. You can talk to it via the .NET API or the C API or the Python API. So this is just here to show you that it's a very powerful device. So you might be thinking of some of the other previous generation products from Aerotech that couldn't do all of this. This is new. As I like to say, this is not your father's Aerotech. This is more advanced, more control, more integration, more connectivity. And I'll also say this. The iXA4 comes with more standard features than previous drives did. It comes with enhanced tracking control, which is really good. It turns your mechanical bearing into acting more like an air bearing, if you can imagine that. The low frequency moves really experience less friction. It comes with G-code support. All the time G-code is supported on the ISMC. And it also comes with the advanced look-ahead features of an Automation1 controller. So tons of reasons to move to an iDrive solution. Call your local field sales engineer and talk more to them about adopting an iDrive for your process. So that's it. That's all I have for you now. That concludes this motion control platform release update. Thank you for watching. I hope you enjoyed learning about all the new features which are available in the 2.7 Automation1 release.